Hey guys, Matt here. In today's video, we're going to find out how well the cheapest PLA I could find on Amazon prints, and if this can be improved further by calibrating the filament. Then at the end of the video, we'll compare this to a more expensive filament. So let's get started. The filament in question is black PLA from Tech Bears, which isn't a brand I've heard of, but at least it's a named brand. And if we open it up and take a look at it, as expected, there are no branding on the actual spool, but it looks pretty good in terms of neatly wound. It doesn't look too bad. But if we open it up, we're going to need scissors for this. Just get a better look at it. It is vacuum sealed very well, actually. Does look quite nice, actually. I don't know how well you can see it on the camera. It's quite a matte filament considering it's just regular PLA. At time of recording, you get this 1 kilogram spool for £8.50, which is pretty cheap. Normally you would have to buy in bulk or shop on AliExpress to get that kind of price. The reviews also seem to be pretty good, so maybe this video is going to go better than I anticipated. First things first, we're going to see how this prints out of the box without any drying. So I'm going to load it up on my Bambu Lab P1S. So now it's loaded on the printer in my slicer, and I'm using Bambu Studio, of course, because I'm using a Bambu Lab printer. I'm going to start with a generic PLA profile. Now I'm going to use default settings besides changing the sparse infill to gyroid because I hate grid. Anyway, of course, we're going to be printing some benchies for this. So I can right click and then add a benchy as a primitive. Where is it? There. There you go. Now we've got a benchy. I'm just going to slice and print using this filament. This will take about 45 minutes, so I'll see you then. To be fair, this isn't too bad for undried, uncalibrated filament. Like I said, on the roll, it is quite matte. Like this is quite a matte finish. There is a decent amount of stringing. Like I said, probably because it's not dried and, you know, things like the retraction settings aren't dialed in, but it's not awful. But anyway, let's dry the filament before carrying out the calibrations. To dry it, I'm going to use the Sunlu AMS heater. This isn't sponsored, but it is a really nice addition to the original AMS. Drying at 50 degrees for 6 hours should do the trick. So see you in a bit. So it's now the next day, hence the change of clothes. So let's see what effect the drying has had on the filament by printing another benchy. Again, using the default settings. So, see you in like 45 minutes, I guess. So, I don't think this is much better than the non-dried one. If I put them side by side, you can see some stringing in both of them. So I guess the stringing probably wasn't due to moisture. It's probably more to do with retraction settings, which is something that will be calibrated. So maybe we can get that sorted. Yeah, just from drying there isn't much difference. So let's get on to the calibration. So because I'm using Bambu Studio, we'll actually have to enable an extra setting in order to find the calibration tools. In other slicers, it's available by default. It's the calibration toolbar, which should be there. But in order to access it on Bambu Lab printers using Bambu Studio, you have to go into Preferences and then scroll all the way down to the bottom. And you're looking for Develop Mode here. So you want to turn on Developer Mode, which will open up other settings as well in the global settings. But the thing we're interested in here is the calibration option, which is now there. I don't know why this is the case. I could speculate it's because Bambu Lab printers are meant to be more rookie-proof, so they don't want people messing with calibration by accident and not knowing they're doing, but I don't know if that's the case. Anyway, if you click on the calibration drop-down, you can see a bunch of different things. So there's temperature, flow rate, pressure advance, retraction test, and then there's a few in the more too, and then a tutorial. If you click on that, it takes you to the Bambu Wiki, and it kind of walks you through what these are. Although it is very limited, the information they give. In comparison to Orca Slicer's description of each of these is very detailed. Thankfully, the ideal order you're supposed to do these calibrations in is the order it's listed in, which is probably why they're listed like that. So we will be starting with the temperature calibration. So if you click on it, it will come up with this pop-up, which asks what filament you're using. So I'm using PLA, so I'll leave it as PLA. But you can see there's a bunch of other filaments there, and then it has an automatically chosen start temp and end temp. So 230 is the highest temperature, and 190 is the lowest, which is pretty good and standard. So unless you've got temperatures you want to try outside that range, I would just leave it as default. And the temp step is 5, so each step will be 5 degrees hotter. So if you click OK, it will generate this temperature tower. If you zoom in, you can see it has the temperatures written on there, like engraved. So 230 all the way up to 290 at the top, so it starts at the hottest. So I'm going to print this at default settings again, besides changing grid infill to gyroid, because again, I hate grid infill. So I've got my generic profile for the PLA, and I'm just going to slice this. This is going to take an hour 20. And if you change the view of the slicing result, you can choose temperature, I believe, change the temperature. You can see it's color coded into the different temperatures. So hotter is green and cooler is pink. So 190 is the top one, 230 is the bottom one. And it has had a little brim, I guess, otherwise this could fall over. Hopefully it doesn't fall over. But anyway, for all the calibrations, I am going to run auto bed leveling each time just to rule that out as an issue, especially for some of them like flow and pressure advanced, which we'll get to, which are more sensitive to bed leveling. So just to rule that out as a possibility, I will get this printed and we'll see you again in another hour or so. Okay, our temp tower is done, so now we can check it out. So as you can see, the numbers are on the side there saying which temperature the nozzle is printing at for that particular part of the tower. So what we're looking for here is the temperature at which the best print quality is achieved. So for things like least amount of stringing, best looking surface quality, and the best quality of overhangs. It's going to be very hard to tell, but you can see some of them way more stringy. So like 215 is quite stringy. Besides 200 and 205 seem to have the least amount of stringing, so that's important to note. And you can also see different types like warping or poor overhang finish. The cooler temperatures have worse overhangs, which makes sense because the hotter you print it, the better layer adhesion you get. Or if you go too hot, then the overhang will not cool efficiently. So the temperature we were printing at before was 220, which doesn't seem awful. There's some stringing there and decent amount of stringing on the left side here. I think 210 and 205 look pretty good, like 210 for overall quality, 205 for the least amount of stringing. So I'm tempted to go for around 210. Another thing you do is try to push out these little bits. Like the easier they are to push out, the weaker the layer adhesion is. Yeah, I think I'll go for 210. So with our result from the temp tower, which I said I was going to go for 210 degrees, we can put that into our filament profile. So we can use that going forward. So that's usually what you do with the calibrations. The result you got from the previous test, you carry forward, so that at the end you arrive at like the most optimal conditions. So if you go into the filament profile, so click on the three dots and click edit. As you can see, the nozzle was already set to 230, which is for the start of the temp tower. So I'm going to change this to 210, which we determined to be better for this. And I'm going to save this as TechBiz PLA as a user preset, and then quit out of that. So the next test to do would be the flow rate. So in Bamboo Studio, there are two types of flow rate calibrations. There's coarse and fine. So coarse basically like a broader range of flow rates, and the fine one is dialing in more specifically. So if I just click on the coarse one, it'll ask me if I want to save. I don't want to save changes, it's just a temp tower. So it's going to ask what kind of filament you want to match with, and you can see what it'll kind of look like. So I'll press OK because I've only got the one filament. So you'll get some little blocks on your plate like this. You can see numbers on them, harder to see, but 20, 15, 10 to 0, and then to -20. So this relates to the flow rate ratio of the nozzle itself. So if I go into the filament settings, what the setting this is relating to is here, the flow ratio. This applies this factor to the total, so max volumetric flow here, which is another thing we'll be calibrating later. So 0.98 of that max volumetric flow is how much will be flowing through the nozzle at any one point. So 0.98 is quite a common flow ratio, but obviously 1 is just 100%. And then somewhere between 0.95 and 1.05, so like 5% either way of the 100% is pretty common. And for the most part, 0.98 is fine, but you might find some under extrusion or even over extrusion, particularly in your first layer. So that's why you'd normally need a flow calibration. Anyway, so Bamboo Studio uses these squares. So if I slice it, it won't really tell you much because they all look the same. And you can change the view result to flow. So that is the thing you'd be looking at. And you can see there is a difference. So the yellow has the lower flow, so -10. So this would be 0.9 or 90% total flow. And then there's -20 and +20. So the +20 will be 1.2 times the flow, and -20 would be 0.8 times the flow. However, this is like an older way of doing it. It's like a legacy way of calibrating flow ratios. It's a bit more difficult because it's using the monotonic line pattern, as you can see on the top. which isn't as easy to tell apart. So I won't be using this method for mine. You can use it, and there are guides on how to interpret it. But you typically do have to do the double pass. You do this one, which is the coarse calibration, which has the plus or minus 20, so it's very broad. And then there's the fine calibration, which does like plus minus 0.05 or something, so it calibrates it more tightly. But because you have to run 2 passes, it's a bit more fiddly and harder to interpret the results. So the more common way to do this these days is use the Archimedean or Archimedean, however you say it, I don't know, top surface pattern, which is a lot easier to use. So in other slices like Orca, this is the option you have. However, for some reason, Bamboo Studio isn't using that yet. But there are models that exist, for instance, on MakerWorld, which use this method instead. You go here, so this model here uses the Archimedean chords. So you can see it's like the spiral looks. This is a lot easier to determine the result from. As you can see here, this designer on MakerWorld has said, so this one is the best result out of all of them because it's got most uniform ridges. But if you look at the other picture, you can see like how bad it can look. So you don't want them too raised or too scratchy like that. You want somewhere in between. Okay, I've downloaded the model and opened up in Bamboo Studio. There is an ironing calibration card which comes with this model too, but I've deleted that because it's not relevant and to make it easier to look at. So this is the flow rate one. So I'm going to set my PLA to my TechBiz PLA so it uses the right temperature. So the nozzle 210. I could increase the first layer temperature to 205. Actually, I think I will do that, because it can be helpful to have your first layer print slightly hotter than your other layers, just to make sure you've got good bed adhesion and a nice flat surface. So I'm just going to save that again. I'm also going to change the flow ratio to 1, so it's easier to interpret the results. So I just have to take the number that's on the card. But if you're doing it, you can do it whatever way you want to. So I'm just going to save that for now. And basically each of these individual pieces have different flow ratios. So you can see the designer has labeled them all as the right flow ratios. And if you slice it, you should be able to see that too. So I change this to flow again. I mean, there isn't such a huge discrepancy. You can see the 0.8 is darker and the 1.2 is lighter because it's got a higher flow ratio. Anyway, you can also customize this, which is quite nice. It has text on it. So you can edit this text to be whatever you want. So I'm going to change it to just TechBiz PLA and quit off that. So now TechBiz PLA is written on there, and then you can change so nozzle, layer height, and line width, which are just the default values, I believe, anyway. And actually, it says 220 degrees. Just going to change that quickly to 210. It doesn't really matter, but you can change that too, so it matches whatever settings you've used. So now I can slice it, and I'm going to print this too to see which flow ratio is best. I'm anticipating that the default 0.98. or even 1 is going to be best, because you normally don't have to deviate much from that, but depends what materials you're using. Obviously PLA is pretty standard and sticks around those values, but if you're using something else like a high flow filament or a particularly low flowing filament like silk PLA, then they might be different. Anyway, let's get this printed. It's going to take another 45 minutes, so I'll see you in a bit and we can analyze the results. Okay, here's our calibration card. I don't know what's happened on the left, it's got a bit messed up. These are the higher flow rates though, so 1.2 and 1.1 obviously off. Basically anything on this left side has got a bit messed up. I don't know if some other print issues happened. So something from this side, so we're looking for the smoothest under or over extruded one. So 0.8 you can see is quite under extruded. 0.9 has some too. 0.95 is okay. 0.96 is okay, and 0.97 is somewhat okay too. So I think it's between these three. It's kind of on the lower side. I think 9.5 has some under extrusion. So I'm thinking 9.6 or 9.7, because 9.8 has more raised ridges on the side there. So I think I'll go for 9.7 for now and hope for the best. Right, so now with our optimal flow rate, we can put that into our filament profile. So I had it set to 1 for that test, so 0.97, so obviously isn't very different to 0.98 default, which was giving good results, so it kind of makes sense. And we're going to save that. I'm just going to go back to this window, because it says calibration enabled. Next calibration is pressure advance. So next calibration will be pressure advance. If you're not sure what this means, basically it's how the extrusion from the tool head varies depending on how fast the tool head itself is moving. So if the pressure advance is bad, you can get bad looking corners on your prints, which are particularly obvious in your first layer. The pressure advance is very important for your first layer. Obviously it's important for all layers, but it's very noticeable if your first layer looks a bit rubbish. Anyway, if you click on pressure advance, you get a few options. There's PA tower, line, and pattern. We're doing PA line, which when you insert it, look like there's nothing there, it just says PA test, but when you slice it, it does insert lines. So basically it inserts lines here with different pressure advances. If you go into your device and filament settings, 0.02 is basically applied to everything, which for the most part is good. So obviously in the preview you can't tell, but when we print this, a lot of these lines might not even exist. If you view it in speed, you can see there's different speeds between the two outer bits and the middle bits, there's acceleration and deceleration. So we'll get this printed and see which gives the best result. So because it doesn't print a model per se, it's more so just little lines on your build plate, I have to get the whole build plate in here. So it does have the numbers on the side, which might be hard for you to see, but you can see the lines hopefully. So you can see at the top with the high pressure advance, you just lose the whole line. What we're looking for is a nice straight line all the way across with little deviation when it's doing the acceleration and deceleration. So anything up here is bad. Then onto the bottom, you can see you get too thin as well. So 0.02 is around here, which is the default. And it is pretty good. On my end, I can see 0.02 does have a bit of narrowing along the center. 0.028 looks pretty good too. So somewhere between 0.024 and 0.028. So the line between. I think we'll go for 0.024. Okay, so now we've got our result, which I said was 0.024. We can go ahead and put that into Bamboo Studio. So in other slices like Orca, you go to the filament profile and it will be here. So for example, if I just switch over real quick and show you filament profile, this is Snapmaker Orca, by the way. Flow ratio and pressure advance, it's here. So by default, it's grayed out. So you just click enable pressure advance, and then you write in your value here. However, Bamboo Studio doesn't have that. So it's not here. So you can go to the device page. And if you click on your filament, you see the factor K is there, it's grayed out. So what you apparently have to do is go to the calibration tab. So you can do flow dynamics and flow rate here. So flow dynamics is the pressure advance. So if you've got a newer Bamboo Lab printer or any new printer, you can do flow calibration before you start a print. That's what flow dynamics is. It's very confusing because flow rate is the amount of material coming through the nozzle, and then flow dynamics is the pressure advance, so the K value. So if I go manual calibration, this is how you'd actually have to do it if you hadn't done this before. Choose all your information, so nozzle, plate, so I'm using a cool plate, and then which material you want to calibrate. So the generic PLA in slot A3 is one I want, and then the method line or pattern, so line, and you can choose K value from and to. So the one I ran previously was to 0.1, but I know I don't need that anyway. And then you have to click calibrate, and it sends the same line calibration print to the printer. So I've cancelled that now. And now I can click next, where I can now write in my K factor. Totally, this is stupid compared to otherwise. I don't know why this is the case. Bamboo Lab, if you're listening, just please add the ability to edit pressure advance in the filament tab. Please. Anyway, I'm going to write 0.024 here, which is the one I found. And I'm going to write TechBiz PLA there and click finish. And it's saying this has been saved to that specific printer. I don't think I can use it for other printers. So now if I go on here, you can see there, K 0.024. Factor K has been changed, and I've now got multiple pressure advance profiles. So that's cool. But if you have a printer which can do the flow dynamics calibration, you basically shouldn't need to do pressure advance, but it can be useful. But this is a P1S, so it doesn't have that capability. P2S does, and newer ones like the A1, H2C, and all that have that. So do not worry about that. Next on the calibration is the retraction test. So this is to determine how much the filament should retract during things such as filament changes or just long travel on your printer. PLA normally needs some retraction, but not a lot, whereas something like TPU shouldn't have much retraction at all, because if you retract TPU too much and too many times, then you can block your extruder. Once you click retraction test, you'll get the default parameters pop up, which again is probably fine for the most part. So it starts at 0mm retraction and goes up to 2mm with 0.1 nanometer steps. I'm going to press OK. I don't want to save whatever that was. And it adds a little tower like this. So I think it meant millimeter. That was definitely a typo. 0.1 nanometers. My eyes aren't that good. Anyway, you can see it makes a little two towers, so it'll just keep moving between them, and each movement will have the set retraction amount. So the idea is the higher you go up the towers, higher retraction means more stringing. So each little nub on here is 0.1, so it should be 1, 2,
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Yeah, 20, because it's going from 0 to 2. So the first one will be 0.1 millimeter retraction. Anyway, enough blabbing. You can slice this and just gonna print this, and then we can interpret the results. So see you in 15 minutes, this one said is gonna take. Cool. So here's our little retraction tower. Very cute. And there isn't much stringing at all, so that's pretty good. So I don't know why we got so much stringing on our benchy earlier. Either way, we're probably not going to need much retraction. There's no reason to have the high retraction if it's not necessary. So I think I'll just add some very small retraction, say 0.4 millimeters, just so we have some retraction. But yeah, success, I guess. So we can put our retraction settings into the filament profile. So if you head to setting override, this is where you'll find retraction. So you can see the default retraction isn't turned on, so maybe that's why it's okay. So if you turn it on, the default is 0.8. We're just going to set it to 0.4, just have a small amount of retraction, which can be useful for like long travel times, but we don't need much because there's barely any stringing on the tower. So I'm going to save that into our profile, and there's one last test we're going to do today, which is under more, which is the max flow rate. So this is determine the max volumetric flow rate. There's also this VFA test, which I won't be covering today, which is to determine the maximum like outer wall speed and resonance frequency of the printer to avoid defects on the surface. Even the max flow rate isn't 100% necessary, but I'm going to do it anyway. So as you can see, it starts at volumetric speed of 5 and ends at 25. I can't remember if this is the default. This might be the default. And it increases in increments of 0.5. So Bambu Lab filaments on Bambu Lab printers can print up to 22 by default, 22 millimeters cubed, that is, of the volumetric speed. Whereas if you choose the generic PLA, so I quit out of that quickly. Go in the generic PLA, the max volumetric speed is 12 if you choose generic PLA, which is quite low. PLA can definitely be higher. So even for like a cheap generic PLA, you can probably get up to about 16, which will speed up your prints whilst not sacrificing any print quality. So we're just going to insert that max flow rate. We'll have it as 5 and 25. I don't want to save anything. I don't know what this means, so I'm just going to click OK. So it inserts a model like this, and essentially after printing, what you're going to look for is where the surface quality degrades. So once it gets to the high amounts, so like the 20 plus volumetric speed, it's probably going to completely fail and just be maybe a bit of a rat's nest. We'll find out. Anyway, so if you slice this plate, first how long is it going to take to print? So 50 minutes, and line type doesn't tell us much. However, if we set it to flow, there you go, you can see the differences. So the top bits with the yellow are printing up to like 25 millimeter cubed. Millimeter cubed per second, rather. So you can see the different flows. So again, I'm just going to print this. I'll do auto 11 again. I'll see you in 50 minutes, I guess. So now there's finished printing. We can take a look at it. So essentially what we're looking for here is the height at which we think the print quality is suffering, and that would be the maximum flow that we can achieve. So again, it's probably really hard to see on the camera, but at the top, you can see these lines appearing. So that's where the print quality is definitely suffering a bit. You see it here, the lines. So we have to be below that. And the way you're supposed to do it, which is a bit unintuitive to me, is use a measuring tool like calipers to measure the height at which that happens. I'm going to take calipers there. Maybe around there. 29.6, it seems pretty high. I think it's performed quite well, I guess. It's really hard to do it with the camera in the way. I'm going to go for that, like 29.6. And then what we have to do is go back to the slicer. So now we're back in the slicer, we can head to the preview and make sure the slicing result is set to flow. And I'm going to find the height at which I said, which seems high to me, but we'll find out. Which was 29.6, and try and find the layer which approximately relates to that. To be conservative, we'll go below it. So 29.44 is the height of that layer. And then if we just move this bar here, you can see it says the flow of this layer. So it says 19.8, which is pretty high, but it's lower than what Bambu Lab filaments have as their maximum volumetric flow rate. So it's not that crazy. But again, to be conservative, it's wise to take like 5 to 10% off what you think the max flow rate is to guarantee good surface finish. So take, say, 10% off. So I'm going to call that 18 millimeters cubed per second. I think that's fair. I'm just going to make a new document and edit it there. So under max volumetric speed, let's put 18 there and save that. So all our changes are made. So volumetric speed, nozzle temperature, flow ratio, which is meant to be 9.7, so I don't know why that's happened. I'm going to change it back. And retraction. I think those were the all ones we did, so I'll save that. So now we're going to finish with a new Benchy to see how it compares to our initial one. Obviously, the initial one wasn't that bad, so this comparison might not be very great, but we're going to do it anyway. And And I'm also going to compare it to a Benchy printed in Bamboo Basic PLA, uncalibrated by me. It's just out of the box performance, but it's a Bamboo Lab printer, so there are filament profiles for it, and they've always been pretty good. So we'll compare it to see how they look. It was getting pretty late, so I decided to leave this to the next day. But anyway, here's our final Benchy using our generic PLA, using our optimal settings. So I don't know how well you can see. I think it looks pretty good, and there isn't a noticeable decrease in print quality considering we increased the maximum flow rate. There is still a tiny bit of stringing, so maybe the retraction isn't perfect. But if we compare it to a Bamboo Lab PLA Basic, which actually looks really good, there's basically no stringing at all on this, and it's pretty good. But in terms of overall quality, they're very similar. And if anything, this generic one looks pretty good. Like, it's a much more matte finish. It's not super obvious on camera, I guess, but this one's like matte PLA basically, but without actually being matte PLA, so that's cool. And I'm pretty happy with how this turned out. So if we just compare it to the very first Benchy that we printed, you can see that this was quite stringy. So in comparison, this is a lot better. Obviously, it's mostly just temperature and retraction that has played a part in that, but happy to see that increasing the max flow rate didn't degrade the surface quality. If anything, you can see the surface of the original one is slightly worse. So yeah, that's great. I'm happy with how this turned out. So that brings me to the end of today's video. I'm actually pretty impressed with how well this PLA printed, especially straight out of the box. It printed really well. And after all the calibrations we did, which was a bit of a long and arduous process, so thank you for sticking with me if you have. You saw at the end that I compared it to the Bamboo Lab PLA, and it's pretty good in comparison. But anyway, I hope you enjoyed it and found it useful. Maybe you've learned something new about calibration along the way. Any questions or comments, drop them down below. Make sure you subscribe so you don't miss any of my new videos, and I'll see you in the next one. Bye!